Standard form. Standard form is a way of writing the equation of a straight line in addition to slope-intercept and point-slope forms. We talked about those two forms earlier, and in the standard form, the variables are both on the left side of the equation. So how does it look? It looks like this. Ax plus by is equal to c. So thing to notice is all the variables are on the left side. The term involving x and the one involving y is on the left, and the right side is just a constant. Here a, b, c are constants, and in addition what we want is a, b, c to be positive integers. A, B, C are, not positive integers. A, B, C are integers, and some people specify that A has to be positive. So what do I mean by integers? What are examples of integers? So integers are whole numbers. Whole numbers are the numbers that you knew in first grade, for example. The numbers that you used for counting, like 1, 2, 3, and so on. And you can also include 0. So integers are the whole numbers and also their negatives. So what are integers? They look something like this. So I can start at 0, 1, 2, 3, and so on. And also I can have their negatives. So -1, -2, -3, and so on. So I'm writing in the order that they would appear on a number line. So these are integers. And look, it does not include any fraction or decimal. So for example, you're not going to find 2.5 in this set or 3/7. You're not going to have any fractions in the standard form. So let's look at some examples. So what are some examples of standard form? I need integers. So let me take 2 for A, then 5 for B, and maybe 100 for C. So that's an example of standard form. And let me write down one more example. And it's better to have A to be positive, so 3x, but B could be negative. So I'm going to take B to be -5, and C I will take 15. See, 3 is an integer, B is actually -5, but that is also in the list of integers. I did not write all the integers, and we cannot write because they go infinitely long in the positive and negative direction. But -5 is also in there, and 15 is also an integer. Now, if you ask what is not a standard form, well, if any of these is a fraction, that is not standard form. And also, if your variables don't appear on the left side, then also it's not standard form. And remember, for a straight line, the variables x and y appear only in the first power, which means you're not going to have x square or y square or square root y, anything like that. Both x and y variables should appear in the first power. Now, actually, I'm going to write down two more examples. See, 0 is also an integer. So can I have one of these three equal to 0? Of course, yes. So if I take A to be 0, then 0x is just 0. I don't need to write that. And let's say B is 4 and C is 7. So this is also a standard form. Now, what did I do? I don't have an x term, which means I took a to be 0. The coefficient of x is 0. Now, if I don't want to have the y term, then I got to take b equal to 0. So this time I will give some value to a. So maybe say 7x, and there is no b term. So if you want, you can think plus 0y, which is like saying there's no y term, equal to say 10. So in the standard form, you may have an equation that looks like this: 7x is equal to 10, or x is equal to 5, something like that. Now think about, so let me write down one more where it's x is equal to 5. This is in the standard form where a is 1 because the coefficient of x is 1. If you don't see any number, there's a 1. Plus, I don't have the y term at all, which means the b value is 0 and c is 5. Now, this is a straight line. This represents a straight line. How does that line look? So if you were to graph x is equal to 5, you're going to find this is x, y, and x is equal to 5 is a line, is a straight line that is 5. So I'm going to look for 5 on the x-axis, and this line goes up and down. It's a vertical line. So vertical line x is equal to 5. Now, a vertical line slope is undefined. So the slope is, let me write it down here, slope is undefined for a vertical line. Notice, you can never write this line using one of the two earlier forms that we discussed. The two forms we talked about are slope-intercept form and point-slope form. So for both of those forms, you got to have slope of the line. Here, the slope is not defined, so you cannot express that. You cannot express this line in slope-intercept form or point-slope form. So standard form can include even vertical lines. So standard form, you can write any straight line equation using standard form. Now the questions could be, how do you graph standard form? So for example, if it is x equals some number, like x equals 5 means it would be 5 units to the right of the y-axis. X equals a number will be a vertical line. So it's either to the right of the y-axis or to the left of the y-axis, depending on what number we have here. But in other cases, we'll talk about how to graph some of the equations given in standard form. I'm going to show you two different methods. So let's make up a problem here. Graph the following lines. So number 1. What if I have 2x plus 3y equal to 6? This is in the standard form, and in the standard form, the best thing to do is to find the intercepts. So what do I mean by intercepts? There are two kinds of intercepts, x and y. So x-intercept is the point on the x-axis where the line cuts it. So how do I find the x-intercept? So to find the x-intercept, I know it's a point on the x-axis. So on the x-axis, every point has y-coordinate equal to 0. So I'm going to plug y equal to 0 in my original equation. So what do I get? I get 2x plus 3 times 0. Remember, y is 0 equal to 6. And I will simplify and solve for x. Look, there were two variables earlier, and now we plugged y equal to 0, so there's no y, and there's only one variable. We can simplify and solve. 3 times 0 is just 0, so 2x plus 0 is just 2x is equal to 6, and I can divide both sides by 2, so that gives me x equal to 3, which means on the x-axis I measure 3. So this is the x-intercept. Similarly, I'm going to find the y-intercept. What is the y-intercept? Y-intercept is a point on the y-axis, so I know x coordinate is 0 there. So to plug or to find the y-intercept, I plug x equal to 0, which means now this time it's 2 times 0 plus 3 times y equal to 6. 2 times 0 is just 0. 0 plus 3y is 3y equal to 6. And then I divide both sides by 3. I get y equal to 6 divided by 3 is 2. So I'm going to have 2 right there. So this is the point 3 comma 0, and this is the point 0 comma 2. Because it's on the x-axis, the y-coordinate is 0, and the x-intercept was 3, so I got 3 comma 0 for this. And the y-intercept was 2, so x-coordinate is 0, and the y-coordinate would be 2. And once I have these 2 points, I can join them. All I need are 2 points to draw a straight line. So that's how we can find, or we can graph a line in the standard form. I did not use the information about slope at all because I did not need to. I can get the x-intercept and the y-intercept. And you might have noticed while working out, it so happens that if you're trying to find the x-intercept, it's simply this number 6 divided by 2, because this is gone. 3y, this term is gone, and all you're seeing is 2x is equal to 6, which means x is equal to 6 divided by 2. And similarly, the y-intercept is 6 divided by 3, which is 2. So it's so easy to get the intercepts in standard form. Let's try one more. I'm going to say this time 3x minus 2y is equal to 12. So this time the x-intercept is going to be, I'm going to take y equal to 0. So to find x-intercept, I will have 3x equals 12. So x is 4. And similarly, to get the y-intercept, I'm going to take x equal to 0, which means this term is gone. And then I'm left with negative 2y equal to 12, or y. I have to divide both sides by negative 2 this time. I get y equal to negative 6. So x equal to 4 is somewhere here. And y, so this is the y-axis. It goes up and down. Y is negative 6, meaning it will be below the origin. So negative 4, negative 5, negative 6. So it's this particular point. So let me write down those coordinates. This is 0, negative 6, and that is 4, 0. and then you join those two with a straight line. Okay, so this is one way of graphing the lines in standard form. Find the x and y intercepts. But sometimes what might happen is your intercepts may not be nice integers, they might turn out to be fractions, and then you may not find that on your graph paper. So I'm going to show you one more way, and let's actually use the same examples. Graph the following lines. So I'm going to write down use the same examples, but call them maybe problems 3 and 4. So 2x plus 3y is equal to 6. In this example, I'm not going to find the intercepts, but rather I will convert this to slope-intercept form. So how do you convert to slope-intercept form? Slope-intercept form has just y by itself, which means when you look at the left side, you have a whole bunch of stuff, 2x plus 3y. We need to simplify this down to y, which means the term that has y in it is 3y. We will get rid of the other term, which is 2x. Now, how do I get rid of 2x? I subtract 2x from both sides. So I'm going to subtract 2x here, subtract 2x there. And now, and I've drawn a line through my equal sign. On the left side, 2x minus 2x is gone, and I only have 3y. Now on the right side, I have 6 and minus 2x. But here is the thing. There's nothing wrong with writing 6 minus 2x. But remember, your goal is to get the slope-intercept form, which looks like y equals mx plus b. So you want to have the x term first and then the constant term. So instead of writing 6 minus 2x, I want to write negative 2x plus 6. Yeah, if you wrote 6 minus 2x, you're not wrong. But there's a danger that in the next step, you might incorrectly conclude the slope and the y-intercept. So for now, just remember to write the x variable first and then the constant, because I want this equation to look like y equals mx plus b eventually. Now, I still have the 3 that I need to get rid of. So I will divide both sides by 3. So 3y over 3 equals negative 2x plus 6. And remember, I have to divide the entire right side by 3. Now, one mistake is to simply divide one of the terms by 3. No, you got to divide the entire right side. So this will give me just y by itself. The 3's cancel each other out. And what happens on the right side? So I have 2 terms in the numerator and I have to divide that by 3. So I can write this as negative 2/3 x. If I divide the first term by 3, that's what I get. Plus, I have to divide 6 by 3. 6 divided by 3 is 2. So this is my slope-intercept form. And once I have the slope-intercept form, I can draw the graph. So how do I draw the graph in slope-intercept form? We discussed that in the video on slope-intercept form. So you'll be provided with the graph sheet with all the grids marked. So it's going to look something like this. So where do you begin? You begin with your y-intercept. So let me make a note here. Once I have this equation, y equals negative 2/3 x plus 2, this is in slope-intercept form, and slope is the coefficient of x, which is negative 2/3, and y-intercept is the constant term, which is positive 2. And if you recall how we graphed slope-intercept form, we start with the y-intercept because we know that the graph passes through this point, y-intercept of 2, and slope is negative 2/3. So negative 2/3 means the rise is negative 2, which means I got to go down 2, and the run is positive 3, and then I go right 3 units. So I get this as my second point, and then I join those 2 points. Now this is exactly what we got when we used x and y intercepts. So when we found the x-intercept, it was 3 and the y-intercept was 2. Here we are not saying that we are finding the x and y-intercept. Of course, we found the y-intercept because that's what slope-intercept form has. But you may not get the x-intercept. It may be some other point. But the line would be the same. So that was the first problem. And in the second problem, we had this was the problem. 3x minus 2y equals 12. I'm going to write that again. 3x minus 2y is equal to 12. And convert this to slope-intercept form. So just like in the previous problem, I will subtract 3x from both sides to get rid of 3x on the left. And then I'm left with negative 2y. And one common mistake is to ignore the negative there and just say that you have 2y. No, you have negative 2y. And again, just like before, I'm going to write negative 3x plus 12 rather than 12 minus 3x. Now to get rid of the negative 2, I will divide both sides by negative 2 because I need to have just y by itself. Negative 3x plus 12 divided by negative 2. So that would give me y by itself. And negative 3 over negative 2 is positive 3 over 2. Negative 3 over negative is positive. And then 12, positive 12 over negative 2 is negative 6. So now my slope is positive 3 over 2 and the y-intercept is negative 6. So if I were to graph that, I start at the y-intercept, which is negative 6. So this is negative 6. And the slope is 3 over 2. Positive 3 over 2, which means I will rise 3 units. 1, 2, 3, and run 2 units. So this would be the second point, and then I join those 2 points and draw a straight line. Now, I did not find the x-intercept here. The second point was not on the x-axis. When we found the intercepts, we found the x-intercept to be, so let me show you, we had x equal to 4 and y equal to negative 6. We still found the y-intercept to be negative 6 here. So this is 0, negative 6. But this point is not on the x-axis. But the line that we obtained here when we used intercepts and the line that we obtained here when we converted to slope-intercept form and then drew it is going to be the same line. This line will also have the same x-intercept as the one that we found when we use the intercepts. So 2 ways to graph in the standard form. One is to use the intercepts, find x and y intercepts. The other way is to convert it to slope-intercept form and then use the slope-intercept form to draw the straight line. right? Now that's all I have for standard form. I'm going to have some practice problems. So the practice problems for standard form are here. Find the x and y intercepts, if any. Remember, you may not have one of the intercepts. If the line is parallel to the y-axis, like we saw, x equals phi is a vertical line. It's not going to meet the y-axis, which means there won't be any y-intercept for that line. So I'm saying find the x and y-intercepts, if any, of the following lines. So you know what to do. To find x-intercept, you plug y equal to 0. To find y-intercept, you plug x equal to 0. And sometimes you may not have one of the intercepts. So do that. And then find the slope of the following lines. So to find the slope of the lines, you need to convert to slope-intercept form. And there is one other way to find the slope in the standard form. It's simply, I've not mentioned that, but I guess I can give you the shortcut. So let's go back to the original standard form. This is the standard form, ax plus by equal to c. And the slope is the opposite of a over b. So if you can remember this, then it's so easy to tell what the slope is going to be. So in this case, for example, 1, it would be negative 2 over 5. It would be negative 3 over negative 5, which is positive 3 over 5. And sometimes, if you don't see x here, that means it's 0. So 0 over 4 is just 0. But for equation 4, it's going to be negative 7 over 0. Well, that is undefined. And so this line has undefined slope. So you can use that formula. It's a shortcut. Now you would arrive at the same slope if you converted this to slope-intercept form. And in the slope-intercept form, you know how to find the slope. So these are the problems, 2 sets of problems. In the first set, I'm asking you to find x and y intercepts, and in the second set, I only have 2 questions. You have to find the slope. So if you know 2 different ways, I would recommend doing them in both ways. That way, your understanding gets stronger, and if you get the same answer 2 different ways, then your confidence level will also go high. You know that your answer cannot be wrong. And on the other hand, if one way you're getting one answer, the other way you're getting a different one, then that's an opportunity to look into where you went wrong. So that's all I have for this, and I'll see you in the next video. Thank you.